let's wait for a few more minutes. Let's see someone else will join, and then we'll start. All right, everyone, let's start with the bootcamp. So, hi everyone, my name is Prajwal Pansare. I work as a DB mentor at DTG, and we would formally like to thank VIT Vela for giving us this opportunity and collaborating with us for this bootcamp. The basic motto of this bootcamp is to learn is wireless charging, really implementable. So, yeah, I'll, yeah, sure. There's someone raised the hand. Yeah, would you, someone like to speak something? All right, let's continue. That might have been a mistake from someone. So yeah, as I said, uh, I work at ATG. My basic work is to look into the EV side of the things and check what's the latest trends, what sort of job opportunities are there in EV and everything. So I'm really thankful once again for VIT Velo to organize this collaborative bootcamp. And I'll share my screen, and once my screen is visible, if possible, someone could just let me know. Is the screen visible?
Yeah, but your voice is very low. Can you
Uh,
raise?
all right. Am I audible now? Hello.
You are audible, but
Yeah, yeah.
voice is not that much of audible. Like you can
Okay,
increase your
okay.
voice. Just check your system's speakers.
Yeah, sure, sure. Just give me a second. Yeah. Could someone just check if the audio is clear now?
Yes,
All right. Thank you. So my screen is visible, right?
Yeah.
Gotcha. So let's begin. The overview for this bootcamp is as follows. We'll first have a little bit of briefing about what exactly is EV, and then what sort of EV chargers or systems are already existing in the market, and then we'll go into a little bit of the methods that wireless charging is being implemented with, and then we'll have a short introduction on how it is being implemented in mobile phones, and then we'll move on to is it really implementable for EVs or not. So basically, EV is a short term for electric vehicle in which the vehicles are usually powered with electric motors. Is the audio still causing some issue?
No, no, you are audible.
Yeah. Okay. So as everyone might not be aware of, EVs are not something that has been introduced in the market recently. It has been a long and existing thing since 1828, and then various several discoveries were made along the road along the centuries to make it more feasible and practical. And EVs had their ups and downs over the centuries. It was introduced way back in the 18th century, but due to the complication, sorry, 19th century, due to the complications regarding its range and its feasibility for the power output and everything, it was not practical back then. So basic types of EVs are as follows: battery electric vehicle, which is a vehicle which is totally powered with the help of batteries. Then we have plug-in EVs, in which you have to plug in them and charge the battery. And then we have hybrid electric vehicles, in which we have just give me a second. Yeah. So in plug-in hybrids, we usually have to plug the batteries. They have a smaller capacity as compared to micro hybrids, mild hybrids, or fully hybrid vehicles. And then we also have something called as fuel cell electric vehicles, in which the batteries are not as big as your regular battery electric vehicles, and the major driving source of energy is a hydrogen tank, which produces the electricity to drive the vehicle. And there is an auxiliary battery which supports all the auxiliary and uh, auxiliary things such as your lights, your AC, and everything. Types of charges. So we'll now dwindle into what are the various types of charges in EVs. There is something known as vehicle charge, which is the plug-in charger in your home, which you plug in your socket and charge your EVs. They have the standard 3.220 volts plug, 240 for UK and other countries, and they need to be installed with caution and they need to be operated very cautiously. And we have something called as AC charge, in which uh, there is there is a wall box which is being installed. It acts as a mediator, and it amplifies the amount of electricity that is being sucked into your car, due to which your car is usually charged 3 to 4 times faster than your regular trickle charge. And then we have DC fast charge, in which approximately 80% of your battery is charged in about 40 minutes to 2 hours, which is the most which you can find in your. Yeah, someone is someone speaking? Yes, you want to speak something? Hello. Yeah, Mohammed.
So can you give example about trickle charge, AC and DC charger? Because some
Yeah, yeah,
just now I joined. Just a
yeah.
glimpse. Thank you, sir.
Yeah, so trickle charge is basically the charger which you get with your EVs, right? You plug into your regular refrigerator socket, and which charges your EV. It is a small box usually. You may have seen it in case of Ether or Ola scooters. They usually have this kind of trickle charge. And AC charger is something you might have seen in your malls, right? Whenever you go to the parking lot of the malls, there are chargers nowadays. So they usually use this system. And DC charge is something you specifically find at charge stations, like the proper stations where outside of your car dealerships and everything. So they use a high voltage system, like up to 50 kilowatts is the minimum they have, and this way it charges your vehicles pretty fast. So now we will dwindle into the types of charger sockets. So as you can see, there are various types of charger sockets, and the reason for this is each and every country has various standards uh, for regarding their equipment, right? As we have ARAI in India, right? So what they do is they regulate these charging sockets and the types of chargers that are being produced in the country to charge the vehicles. And there are five pin chargers, 7-pin chargers, uh, as you can see in the image right here, right? So they vary from country to country, as well as they vary from the type of charging current they use. In case of AC currents and in case of DC currents as well, the number of pins, as I said, also vary on the current passing through them. In this image, you can see the various types of charging sockets, right? In North America, they have a 5-pin charger for the AC current, whereas they have a 7-pin charger for the DC current. Similarly, Japan has a 5-pin socket for AC, but they have a 2-pin charger for DC. So it totally depends on the amount of current that is flown through them. The the standardization the country has adopted. In case of EU, you can see the number of pins are up to 9 pins, right, for the DC charger. And in China as well, they have a similar like 9-pin chargers. So the reason for this is we have various committees or associations to standardize the products for each and every country. So there are various methods, as I said, of wireless charging. So the first one we have is electromagnetic induction. You may have heard about it. It is one of the widest used wireless charging method, in which there are two coils, right? Uh, there is a primary coil, a secondary coil. The primary coil is usually seen in your charger, which is your transmission coil, also known as transmission coil, whereas there is a secondary coil in your receiver, also known as the receiver coil. Uh, the major drawback of electromagnetic induction is the distance that it can carry the current. And as you can see on screen, they are very low cost circuit, which is an added advantage to it. and they transmit the power using induced magnetic flux, right? So as imagine there is a primary coil on the left hand side, and there is a secondary coil on the right hand side. So how this works is when the current passes through the coil in the left hand side, it creates an electromagnetic field, which then transfers the energy to the secondary coil, and when the electric magnetic field is generated on the other hand, it produces the electricity. Then we have magnetic resonance, and this the power is transmitted by using the magnetic resonance principle, in which they have resonators at the transmission side as well as the receiving side, and the uh, resonators, they resonate the magnetic field, and they transmit. The receiver on the other hand receives those resonated magnetic fields, and this is the way the electricity is passed on from one end to the other end. This method is usually used when long distance is required and the amount of current that is being flown is not that high. However, due to the travel on the long distance, the efficiency of this method is quite low. Then the other method we have is electric field coupling. So in this one, there are electrodes facing on the power transmitting side and receiving side. They both face each other to form a capacitor sort of connection. And with this phenomenon, the current flows at high frequency. The transmission distance is short as similar to electromagnetic induction, but this is way more costlier than the other one. And the other disadvantage this one has is the increased thickness of the high voltage transformer. And in comparison to electromagnetic induction, the benefit that it has is that the amount of heat generated is quite low in electric field coupling. Then we have radio reception. In this, electromagnetic waves are being transmitted from one side to the other, and as our radio works on the frequencies, right? Similarly, the electricity is being transmitted over radio waves, and this is how this wireless charging works. So we'll dive a bit into how wireless charging is worked in mobile phones. As we have seen the four methods of wireless charging in the previous slide, the most commonly used wireless charging method is electromagnetic induction. Wireless charging, as we all know, is also known as inductive charging. And the reason for this is as they use EMI process for the wireless charging in the mobile, right? So we'll go a bit further, and I'll in this image you can see exactly how the transmitting coil and receiving coil works. When the
Can you
EMF,
move to the previous slide?
yeah, sure.
Yeah.
So as you can see in this slide, right, the power is supplied at the primary coil, and due to the electromagnetic field generation, the power is transmitted from the primary coil to the secondary coil, and then we have two connections through which we receive the electricity. So as mentioned while explaining electromagnetic field induction, the magnetic field is generated when the AC voltage is being supplied to the primary coil, and due to the electromagnetic field generation, the electricity is been passed to the other coil, and this is done when with the help of the electromotive force that is generated, which cancels the magnetic flux generated at the first coil, resulting in creating the electricity on the other side, which can be used to charge the devices. As you can see, and as mentioned, the primary coil, also known as the transmitting coil, is built into your charger, and then the electricity is being passed on to your receiving coil with the help of EMF. And as we all know, there are various parameters into consideration while building the wireless charger, right? Such as the transmission distance, the charging stability, as well as the efficiency. So these factors may vary from manufacturer to manufacturer, totally depending upon the amount of charge they require to charge their mobile phone, the size of the battery pack, as well as how fast and how efficiently they want the mobile to be charged. So now we'll come back to the main topic of this boot camp, which is wireless charging in EVs. So before moving on further, do you think wireless charging could be implementable, is being implemented already in EVs, and if so, why? if someone could just unmute or write in the chat box. Regarding the PPT, I'll check if it is possible. I won't comment on that right now.
Sir, repeat. Can you please repeat the question?
Yeah, so as we have studied how wireless charging works in mobile phones with the help of EMI or all the other methods as well, we have discussed around 4 methods. So do you think wireless charging is actually implementable in EVs? And if so, why? As well as if not, why?
Yeah, it is possible to implement in EV vehicles.
So how? Yeah. Okay. So how exactly do you think we could implement it in EVs? And
Yes, sir. We can be implementing in a electric vehicle, but the complications are very tough, sir. Like for phone, it is a every part is electrical component part, but when comes for EV, it has some mechanical parts, and by implementing the cordless charging, we can the electromagnetic waves will be generated, and there might be some mechanical fixture losses or something we might be experiencing. So that is the main case. And second one, it increases the cost of electric vehicle. Right now, we are having the use taxes for the import of electric vehicles. Then, additionally, we need to spend some more bucks for the wireless cord charging. That's my point, sir. Hello, sir.
Hey everyone, there was some internet issue with the mentor. We'll get back to you. Just have patience, man. Hey everyone, please have patience. Wait for a while. Our mentor will be back in few minutes. There is some internet issue. Sir, you can send PPT.
yes, sorry for the issue, boss. There were some internet issues. Shall we continue where we left? If someone might have answered the question regarding the implementation of wireless chargers, you can unmute yourself and answer again.
Yes, sir. Did you hear the comments, sir, or should I repeat once again?
Yeah, could you please repeat? There was some network issue and I had lost connection.
Yes, sir. Yes, sir. From where, sir? From starting or from middle?
Yeah,
Okay.
right after the point where I asked the question, what do you
Okay,
think?
okay. From starting, I will repeat the points.
Yeah.
So implementing the wireless cord charging, one thing the principle behind this is electromagnetic mm, principle. So electric vehicle comes with mechanical components as well as electrical components. So while charging, there will be some mechanical issues requiring mechanical wear and tear can be seen, sir. Like we can see in with electromagnetic induction, the material will be heatening. I don't know if this principle is right or wrong, but second point is like cost will be drastically increasing. I know the comfort will be increased rapidly, but overall the cost will be increased, sir. That's my point.
Yeah. So, yeah, when we scale something to a larger scale, the major factor is cost, as you have said, is right. Uh, and
Sir,
yeah,
unless and until the distance can be increased, that the range of like how much far the car is from the charging,
yeah,
unless and until that can be implemented, if it is very close to the charging, then it's not like very helpful for the case of wireless. Because anyways, we have to use a wire that has to be close. The car has to be close to the charging station or charging point. So unless and until long range wireless charging is there, I don't think it is very helpful.
So basically, what you mean is the area of effect, right? When
Yeah, yeah.
yeah. So when EMI is done per se, we need the primary and secondary coil to be on top of each other or parallel to each other, is what you mean. So
Yeah.
yeah. And someone also mentioned that the power requirement is large, so system should be strong enough to sustain it. Okay, yeah, that's also right. So now we'll move further ahead. So obviously, since the time the wireless charging has been introduced in chargers, mobile chargers. Yeah. So since the time the wireless chargers have been introduced in mobile phones, we all have been a bit curious, right? In what all technologies or in what all sorts we can use a wireless charging. So to answer that question, yes, the charging in EVs can be done by implementing the EMI principle and the same principle that we have seen being used in mobile chargers. And let me just assure you that it is being implemented already in various parts and various tests are being already conducted. So there are various companies that have already implemented this technology and tried to see if it is actually feasible or not, like BMW, Genesis. So Genesis has acquired a company called Vital City, which is been the major runner in this field of wireless charging for EVs. We also have a UK-based startup known as Charge.gy, and we have a US startup as well, which is Plugless Car, which was formerly known as Plugless, and Qualcomm, which you all may be very familiar with, has also done a significant amount of research and discoveries in this field. And let me just tell you, the wireless charging in EVs cannot just only be done when the EV is stationary. It has also been done by tests have been already been conducted by Qualcomm, in which while driving, you can charge your EV on the drive the same way the maglev train works, right? And the maglev train goes from point A to point B. The magnetic field that is generated between the tracks and the uh, train, it transfers, right? It goes, it pushes the vehicle further and further. So due to which the push cannot just get one point; it has to get continuous push. So the magnetic field being generated between the tracks and the train, it moves along with the train. So the same principle is being implemented by Qualcomm, in which what they have done, they have added around 1/4 of mile of a track in which they implemented this technology and they tested. Uh, the wireless charging pads were being already been placed within the road and the car was being driven over them, in which they have observed that up to speeds of 70 miles, which is your average speed on highways, it was pretty feasible to charge the vehicle. And as I said, Charge.gy, right, a UK-based startup, it has been conducting research in this field from a very long time, in which what they have done is they have had 10 Renault cars induced with wireless charging technology, and they have had various charging points located in and around London city, and they have seen that the charging efficiency is pretty high. We, as I said, by basically is a lead runner in this. They have also conducted various amount of research with Genesis, which is again a prime car manufacturer located in Korea. And BMW, what BMW has done is they conducted a research first in Germany, in which they saw if wireless charging is feasible or not, and they found it to be positive. So what they done, they moved out of Germany into US and they gave gave 10 testers cars fitted BMW 5 Series cars fitted with this technology, and they've seen that it's pretty feasible. And as well as you might not know this name, Kai Siri. He's a US-based engineer. What he has done is that he has created a standard for wireless charging, and the same standardization is being adopted by various standards such as SAEIC and etc. So we'll now move on to advantages. So what exactly does wireless charging provide us? So what it exactly does is it omits the use of cables. We usually have to carry cables, or we have to plug in with the help of a cable to charge your vehicle. It also emits the whole phenomenon of charging socket standardization, which we have seen a few slides back, where there are various standards for each and every charging socket, and it varies from country to country. Then this technology can easily be integrated in your public and private parking places, right? You can have a wireless charger installed in your own private parking place, as well as in public places such as the mall parkings, the Walmart parkings in US. Let's say for US, they have huge Walmarts and everything. So in that parking, we can easily implement this technology. You don't have to worry about the range while commuting, right? In case, as I said, the Qualcomm, what they have done is they have observed that you can wirelessly charge your vehicle while on the go. And the same technology that Qualcomm has developed is been trying to be adopted by two states in US. They have not disclosed the name of the exact states as well as the exact location where they will have, but they are trying to implement it over a 1 mile long track instead of a 1/4 mile to see the actual feasibility and practical usage of this. And if it is feasible, we can see it being used in the future. We also don't need to find specific charges. As I said, there are three types of chargers available right now. There is trickle charge, there is DC charge, and then there is DC charge. Again, within those charging methods, there are various sockets which vary from car manufacturer to car manufacturer as well as country to country. So let's say someone imports a vehicle from US or Japan, which has which is an EV and which has a charging socket fitted according to that country. So you would have to face a lot of fight, lot of challenges to charge your vehicle in that case. You also not need to wait in line, as many of you may have seen this in your locality itself, right? Whenever you go to a dealership which offers an EV, you see a long queue. There are a lot of people waiting to charge their EVs. So you might again not need to wait for it. Let's imagine you go to your local, not local. Let's say you go to a mall to do shopping and everything, and while you're shopping, your car is being charged, so you don't have to worry about how you will reach your home back. There is less charge when you left home. Then you also, as I said, you don't exclusively need to find a charger with the right socket. And what this does is there are EVs which don't have a long range. They usually range from 60 to 80 kilometers of range, like your public transport buses. So even they don't have to face a problem where they might, think of having not enough charge to cover the journey. As you're commuting, your vehicle is being charged, so you don't have to worry about the range anymore. But the major disadvantage this technology has is significant amount of discoveries have not been made yet. The initial investment is also pretty expensive. It's a time consuming process for installation, right? It is not easy to install wireless chargers. Then let's say if a government takes initiative and thinks of implementing a wireless charging in a parking spot or a parking lot, it would take a lot of time, as well as it would take the whole reconstruction of the parking lot to implement this technology. You also need additional sensors to ensure the equipment that is being used in the EMI is cut off when there is no vehicle on the charging pad, as well as, let's say, if a human is present in the car, you don't need to you don't need the EMI to be conducted right at that time, as it is pretty harmful for humans, and it can also have adverse effect. in case there is an animal, below your car. In the rainy seasons, usually the animals tend to go below your car to avoid the rain and everything. So in that case, if the car is being charged, it might be harmful for that animal, as well as the malfunction of this equipment may create a large EMF, which may also cause various other problems around the charging point as well. And the other disadvantage is that in order to ensure the wireless charging, the cars need to be EMF proof. You may have seen in few movies where there is an EMP being charged, which disables everything, each and every electronic in your vehicle. So due to this, while you're on the go, it may cause you further problems with the electronics of the device. So we'll before conducting the review of this wireless charging session, let us see if anyone has any doubts or any queries regarding.
Yes,
Go to the previous slide.
Yeah, sure.
Just go to this types of charging you had, right?
Types of
Types of charging. So you had 3 to 4 types of charging.
the methods of wireless charging, you mean?
Yes, yes. So here, which is preferable for in Indian roads and for Indians? So we have you have 4 types of charging you have introduced here.
Yeah, yeah.
So which is possible and which could be fine for Indian makes?
So it's not about just Indian things, right? So electromagnetic induction is being the majorly used wireless charging method. And the reason for this is that it is highly efficient, it is pretty cost effective. You can also use and implement the other methods, but then the cost may go high, the efficiency may go low. So there is always a sweet spot between things, right? So EMI is a sweet spot when it comes to wireless charging, as it has pretty high efficiency, as well as the cost required to make a wireless charger using this principle is quite low.
Okay, so you are saying that this inductive charger is good for as a good method for wireless charging, right? So while charging, does it affects a lot as because electric field, electromagnetic field, within the surrounding will affect this nature and even our human health, right?
Yeah, radiation and the radiation that is caused due to the EMF. You're right. So what, as I said, Kaisi Lee, who has been working on the wireless charger and standardization, what they've done is they've conducted various research on this. As wireless charging, when it was introduced for your mobile phones, people thought that the radiation might be too much, but radiation is being generated pretty much by any electrical appliances that is around you. Yeah, but the amount of radiation is usually small. But when it is scaled, yes, it might cause a huge issue. So in order to avoid that, they need to set a few parameters, right? The amount of charging that is being induced with the EMI, it should not exceed a certain limit. After a certain limit, it is really harmful. So that's why I said it is a huge disadvantage to implement this technology unless and until we are very sure that there might not be a malfunction in the uh, wireless charger, because if there is a malfunction in that, then the amount of electricity that is being produced may exceed the standard amount, which may cause adverse effects.
Okay, while comparing with this wired and wireless charging, so that is this wireless affect the battery as such while comparing with this wired?
Uh, as wired and wireless, right? Both, if
Yeah.
you overcharge a device, they tend to affect the battery. But nowadays, as you may have seen, there is something called a smart charging, right? In which, if your phone charges above 100%, it stops to take the charge from the charger itself. So there are sensors in your mobile phones as well, that once your phone reaches 100%, even though the switch is on, the phone will not take any extra charge in. So the same principle can be implemented in wireless charging, as well as it is already being implemented for mobile phone. The same principle can be implemented for EVs, in which if your EV reaches 100%, the EMI is cut off. So the induction is totally cut off, due to which your vehicle is not further charged.
Yeah.
Yeah.
So,
Yeah,
so
sure.
why do we need wireless charger?
So as I said, yeah.
Yes, because IC engines and normal electric vehicles, we can see a huge graph. Like there are many classes like environmental issues, air pollution, and one is noise and like various pollution. But EV stands apart from that. But when compared, if we see wireless charging and with wire cord charging, I can't see much difference between. Only for the sake of comfort, we are implementing and we are focusing on the improvement of technology regarding wireless charging. But I don't see much future of wireless charging. Okay. Because only
Yeah.
one part there is only for the sake of comfort we are utilizing our time on implement. Yes, sir.
So I get it. Your point is why introduce something that is not necessarily beneficial. But unless and until something is been introduced to us, we don't find the benefit in it, right? Now we were never introduced previously to EVs as Indians. We had an idea about it, but we were not introduced in practicality. So we thought, what is the use of EVs and everything? But once they were introduced, we saw the good side of EVs, that it actually helps the environment and everything. It reduces the emission. Similarly, when we will introduce wireless charging, what it will do is it will not just only give you comfort, but it will also increase your productivity. Now I'll tell you how it will increase the productivity. Let's say you go from point A to point B for your work daily, and the range of your EV, let's assume it's 300 kilometer, but the distance you have to travel for 5 days exceeds it a little bit, and you have to so at the end of the fourth day you might need to plug in and charge your vehicle, right? So what that will do is you will have to remove a certain amount of time from your daily work to ensure that your vehicle is being charged. But in case of emergency, like let's say there is some emergency, there is a medical emergency in your family, and your vehicle is not charged, and you live in a remote off area. So in that case, what you will do, it will take some time for the ambulance or the taxi to arrive. So in that case, if I have wireless charging, and the wireless charging is only being implemented when there is no charge in my vehicle, right? So what I'll do, I'll just park it in my garage. My vehicle is being charged. I don't have to look after the plug. I don't have to plug it in. I don't have to make sure that switch is on and my EV is being charged. I just leave it in my garage. I just go. I do my chores, and when I come back, the EV is already charged. And let's say you're going on a long journey. Now, as I said, they are also exploring the idea of wireless charging while you're on the go. So what that will do, let's say you're going from point A to point B. You're going from Bombay to Goa. The distance is around 400 kilometers. The maximum range your EV can offer right now is 300 kilometers. You have to do at least two stops to ensure that you reach your destination without any hassle. But if this technology is being implemented, you're just riding on the road without any worry. You don't have to make a certain number of stops just to charge your vehicle. You just make one stop for lunch, one stop for your evening snacks. That's it. That's done, and you're on the back on the road again. You don't have to worry about the range. You complete your journey. Again, this point. Then another point that I would like to make is, let's say, your sorry. Another point I would like to make is, I just let's say, even though there is not charge on the board, but there is just wireless charging. You just take a break for your lunch. You just leave your car in the parking lot. You don't have to plug it in or anything. You just go, you just leave your lunch, come back, your vehicle is already charged. You're back to go. So that's why I think it is more practical to have wireless charging instead of having wired charging. And even in the public transportation sector, it is very practical. Let's say there are if you have wired charges, there would be a limited number of plugs, right? But if you have wireless charging, you just park your bus, you just do a little walk, you come back, your vehicle is charged. When you remove your vehicle, park another vehicle, you don't have to plug it in again. As I said, you don't have to wait for longer queues. You can implement it throughout. Let's say that's a bus depot, right? And you have a continuous charging when you're even parking the vehicle or even you're turning. That might give you extra 1 or 2% of charge. So I think it would be pretty helpful.
Sir,
Excuse
Yeah,
me, sir.
sir, just to clarify, so what
yeah,
you're trying to say is when there is no access to a charging station, a
yeah,
wireless charger will be helpful. Correct,
yeah,
sir?
yeah.
Sir, so what I'm suggesting is, Okay, since wireless charging through electromagnetic induction is the efficiency is slightly lesser compared to, let's say, wired charging or cable charging, correct, sir?
Pardon?
Slightly reduce efficiency, correct?
Yeah.
While compared to a wired or cable
Yeah.
charging
So
method.
let's say right now your wired charger uh, obviously has 100% charging efficiency.
So, sir,
And
my question is, why not build like a portable cable which you can carry with you, and that will also offer you higher efficiency, and you can take it along with you instead of carrying let's say, a wireless charger. You can carry that portable cable along with you, and whenever you can find, let's say, power source, you can just connect your, let's say, the cable to the power source, and you can directly plug in your vehicle through that, right? Instead of using a wireless charger.
but as I said, the charging of an EV requires high amount of current. You may not find necessarily high amount of current everywhere. And if, let's say, in case of emergency, even though you have the cable, uh, would you go knocking on the door of each and every person and
Or
ask
like,
them that, yeah, could you help me charge your vehicle? Yeah, you
true,
see,
sir.
that's the
Understood.
issue. That, yeah, yeah. So again, that is the question. So what this does is it also gives you a bit of privacy in scenarios such like this, right? No one would disturb you. You don't have to disturb anyone.
Right, sir. Understood.
Yeah.
Sir,
Yeah, Vishnu.
sir, I want to keep a point that recently we have seen many issues regarding the temperature problems with the batteries.
Yeah.
So, as far as I know, that electromagnetic induction also creates, with the charge transfer, it also gives more amount of heat also.
Yeah, yeah.
So,
Right.
I feel like it will surely affect the battery as battery and other components in the vehicle, as many components are temperature sensitive, and continuously we need to have some cooling devices in it so that the temperature is maintained. So I feel like if we use wireless charging and continuous for a continuous duration of time, we are plugged with electromagnetic induction with our vehicle, so it will create more heating will be more, and nowadays we can see the issues with the blasting of batteries are more, so the risk of those things will increase again, right?
Yeah.
And also it would increase the global warming also, like if you will think far enough to the topic, it will anyhow lead to global warming also, because it will create some of the heat through radiations also while charging and discharging.
All right. All right. So yeah. Okay. So a few good points made there. Yeah. Whenever
So
EMI.
we should use more thermal resistance those devices in our vehicle.
Exactly.
Again, those all parts will be costlier, and now till now it is not being made so easy to buy for normal people in India.
Yeah. Yeah.
So going to the wireless charging is a far big topic from here. Like,
Yeah.
first of all, we should construct ample number of wired charge points, right? After
Yeah.
that, we will switch to wireless. So I feel like this would create more heating problems. And
Okay.
for that, we should also like think about this thermal resistance also in our vehicle.
Yeah. A few good points made. So I'll address those points one by one. The first major point you made was the amount of heat generated in the EMI, right? So as I said, there are being standards for EMI to ensure that wireless charging is being conducted safely. Yes, it, EA said EVs are safe, yet they still at fires. So the the heat generation is not the only major reason behind this, right? There could be various reasons, such as in case of the Ola fire, the reason was design that was that is being utilized by Ola is not made by them. It is being taken from a Swedish company where the temperatures are pretty low. So what they did when they did the calculations for the battery design and the power distribution and everything, BMS and everything, they made it as per the country that they are living in, right? So in Sweden, the temperatures are pretty low, so they made it accordingly. But India is a very humid and hot country, so that's why Ola caught fire. And the other reason for the fires could be failure of BMS, right? If a battery management system it has some fault, it fails again. So what that does is there is nothing to look after the amount of electricity that is being going out of your batteries into your motors and everything. The amount of there is no proper cooling of the batteries. due to the failure of PMS, that might get you fires. Coming to the global warming point, so let me just clear it up. Global warming is not just caused by the heat. There are various other factors. The major reason is the greenhouse gases that are being emitted by the IC engines. So what they do is the greenhouse gases that are being emitted by the IC cars, when they go up and they react with the oxygen present in the ozone layer, they form oxides, and that's how the ozone layer is being depleted. So that's a major reason for the issue regarding the global warming. Then, yeah, as you said, the cost, obviously, as I mentioned in the disadvantage, the cost is pretty high. The cost of the EVs was also pretty high at the start. But when you mass produce something, uh, the cost of manufacturing reduces significantly. So that way the selling cost is also reduced significantly. So once you get into this sector and you mass produce something, the cost will significantly drop. Yes, it will still be pretty expensive when you compare your regular charger to a wireless charger. The wireless charger is obviously still more expensive because your regular charger does not use EMI to charge your phone. So that's why. But if you invest it on a larger scale, if you implement it on a larger scale, I personally think wireless charging would do wonders. Someone had a
So,
question. Yeah,
so why can't we use solar in itself? Like in mass production, as you said, till now we know that solar is a good source of energy, and for India, like Indian, we are near to equator and we get ample amount of heat every year. So why can't we use for solar? As we know that already it is going higher in price.
Okay, so what you're saying is implement solar panels on your car and then charge the vehicle while it is moving, is what you're trying to say, or are you trying
Yes,
to say?
something like that only, sir. Some receptors which will help you to like continuously. It will be generating power for your vehicle, and you need not to stand anywhere for either wired or wireless charging.
Okay, okay. So
So,
again,
so,
yeah,
so,
yeah,
so so by implementing solar, the mainly the aesthetic, the looks of the vehicle will be
yeah,
damaged, and the craze for open roof, it will be
yeah,
a negative advantage,
yeah.
and it works
Anyhow,
only
on
when the
sunny days, you won't prefer to open your roof and go, no, sir. In sunny days, very sunny days, and also nowadays we are preferring for dark colored roofs. I have seen many cars and people they prefer buying roof with black shades, even darker shades other than the body. So they take darker shades. So we can implement like solar panel doesn't look with that graph like structure only. We can implement it as black also. It doesn't looks like solar panel actually, but it used to be.
Okay, sunny days, yeah, pretty feasible. What about the rainy days or cloudy days? In winter, we have less sunlight. So in that case, it becomes pretty impractical to implement something as solar panels, right? In that case, so in that case, it won't be as cost effective as EMI. I have a wireless charger at my house. I don't have to worry about it being charged using solar energy, right? I don't have to worry about rains. I don't have to worry about cloudy weathers. I don't have to worry about to charge my vehicle only when the sun is out. In that case, yes, you can uh, use wired charging. But again, I can come back to the point in case of emergency, what would we do? And again, someone raised a point if we are charging the EV wirelessly in static condition, so why not use the wired charging for more efficiency? As I said, Qualcomm has already conducted various tests on charging on the board technology. So what if we implement not just wireless charging in static condition, but on the go driving conditions? Then in that case, both may work hand in hand, right? We can have wired connection at static conditions to avoid more amount of electromagnetic field generation, and you can have wireless charging on the go kind of thing. Introduction of wireless charging doesn't mean that the wired charging would totally go off the grid. It will still be there because the efficiency, as everyone is pointing out, is pretty high, and it would be, as it would be a bit cost effective when compared to wireless charging. So yes, we can implement wired charging in few places, but implementation of wireless charging in few places is not a bad idea at all. Is what is the point of this whole technology. Uh, Anyone else has few questions? As for the Rishma might have said something like the amount of heat generated in EMI is more less. So we can focus more on the cooling things, right? We could have a efficient cooling technique. We could implement insulations every now and then to avoid the heat transfer. We could isolate the wireless charging components a bit from the other EV components, which are heat sensitive. We can do things like this, which are pretty easy. Like design point of view, once you think the initial design will be a bit hard, but once you implement it, you can just make a few changes, right? There are various vehicles that work on the similar chassis body. So once you have designed the chassis accordingly, we can use the same chassis and scale it up and down depending on if it is a sedan, if it is a hatchback, if it is an SUV. That's what is being done. So similarly, if wireless technology is being introduced in a specific sedan, let's say Honda introduces it in Honda Civic, it can also be done in the Honda hatchbacks, Types and everything. It can also be done in Honda SUVs. That is the point. Introduction of wireless charging would not necessarily mean the eradication of wired charging, right? It is similar to introduction of EVs. It's not going to ensure eradication of IC vehicles. IC vehicles still would be for many years down the road, at least till 2060 or 20. I think at least till 2060 or 2050, you would still see IC vehicles being a major part on the road. It is not easy to go from one thing to another, right? Even if you want to quit a bad habit, it takes at least 21 days to quit. So similarly, when we move from one technology to another, it is usually done in phases to ensure that we don't face as much difficulties along the way. And if there are any, let's for an example, let's say there is a software update in your phone, right? When the initial software comes in, it has a lot of bugs, but they don't but nowadays what Windows has done is they provide the software upgradation in parts. Let's say 10,000 customers this week received an upgradation from Windows 10 to Windows 11. So what they do is they at least give 2 weeks to see if there are any bugs in practicalities. Once they see those bugs, they fix it, and in the next week, what they would do is instead of 10,000, they would give it to 20,000. So that's how we move. We move in phases. Any other doubt? If any one of you have any other doubt or any other, something that I might not be aware of, you can share your point of view, your point of knowledge, which might, create a curiosity in me as well. Like, yes, that could be a practical problem. How would we tackle it? We can have a discussion on that.
Compensation, motor vehicle compensation acts, because for motor vehicle there is an law called in 1982. Revised version is 1982, and recently in 20s they have upgraded it. So, is there any chance that even the EV will fall under Motor Vehicle Act, or does it come up with a new phase?
So what you mean is the BS4, BS6 norms is what you mean.
No, no, that is a overall the Europe
Yeah.
point, but I'm talking about compensation, Motor Vehicle Act,
Okay.
something
you
related to judiciary.
could you explain a bit more? I'm unable to get what you exactly mean.
Like, there is a law called Motor Vehicle Act, sir, and on which the every vehicle falls under that, sir. So let's take if there is a vehicle met with an accident or something, robbery, loan, etc. Everything comes under that only, sir. So the court will be giving the solution based on the prescribed rules, like traffic rules and violations.
Okay.
And
So you're referring to the Motor Vehicle Act when it comes to insurance claims, right?
yes, 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 but not actually in insurance claim, but I'm entering into the accident compensation side one, because the EMI loans and everything is similar, and everyone knows the EMIs and all that stuff. But my point is regarding accidents and compensation, because the compensation right now is very low. Like if a person met with an accident, the compensation cost is around 5,000 for the debt, and the partially disabled or something, the cost is around 2,500 rupees or something. So can we change this one in EV, or will it
So you
come with
mean
the
the
plan?
compensation? Let's say if there's an accident and the manufacturer is at fault, the compensation the manufacturer provides to the person who has faced the
No,
accident.
not manufacturer, the insurance company or
Yeah,
the
yeah.
party.
Okay, okay, yeah, I got it. So the compensation between two parties. Okay, okay.
Mm.
Yeah. So it totally depends, right? I don't have any idea about it, but there might be some. This might be something to be considered by the government itself. So they might want to bring in laws in which the compensation provided is pretty hefty, like 5,000 rupees for someone's death is nothing. So this might be something to be thought of. But it depends, right? Why would someone from the insurance point of view would want to have an accreditation in this law? They want to save as much money as they want again. So it totally depends on the government, what the government stake is on this. I can't have a say in this per se. But yes, obviously, as someone who uses vehicles, who sees vehicles on the road, obviously, yes, I would want the compensation to be a bit more, way more, not just bit more, way more than 5,000 and 3,000 rupees. So it, it is not something that, I can have a say on. But yeah, that's a fair point. I hope with the new implementations regarding the EV laws, the government does something about this as well along the way. Uh, so, anyone else has any other doubt?
Hello,
Yeah, yeah, Adit.
sir. I want to multiple uh, advantages in EV. A new project for anything advanced.
I'm sorry, I did not get exactly what you mean. So
Sir,
what?
I
Yeah.
want to I want to uh, controlling kit how to implement.
So are you referring to the communication protocol subsystem or anything like that?
Sir, yes.
Okay, okay. So we, I don't know for which segment, but yeah. So communication protocols, you yes, you definitely can study and create your own subsystem. It is a pretty good project. I myself did something on that. I don't think the colleges in India share enough knowledge on this thing. Communication protocols is something that is not just being implemented in EVs, it is also being implemented in your IC vehicles as well. So what communication protocols does is it reduces the amount of wiring by having just two wires to communicate within the various ECUs by using protocols such as CAN, I2C, UART, Link, FlexRay. These are the various sort of communication protocols that can be implemented. If you do enough research on it, yes, you can create your own subsystem. There is a standard for this by SAE. I guess it is J1939. So if you explore that standard, the coding is it is already been pre-coded. So what basically varies from manufacturer to manufacturer is the variables such as, let's say if you have the temperature sensor in your vehicle, tire pressure sensor in your vehicle. So it varies from the manufacturer to manufacturer. How it varies is you may use different types of tires. You may use different companies of tires. As per your calculations, the ideal pressure in your tire should be so and so. So you can code it accordingly and you can monitor it accordingly. But let's say this is the least amount of pressure that should be in your vehicle. So you can have it coded up. If it is below, let's say 20 psi, that your vehicle might go into the state of wobbling. So in that case, what you can do is you can pre-code it as per the sensor you have, and you can pre-code it that once it goes below this amount, it will flash on screen that you need to instantly refill. If it is above a certain pressure, again that causes various issues. So you can then code it accordingly as well, and you can create your small subsystem. You can play with the sensors, various sensors. You can play with the various components. You can create a subsystem just for lighting as well. You can use a single ECU. You can use multiple ECUs. So you can play with communication protocols a lot. Anything else?
No, sir.
Yeah. So if no one else has it out, I
Sir,
think, yeah,
sir, lecture और कितने होंगे सर?
wireless charging. This is a boot camp, so this is not a lecture. What exactly do you mean by lecture? I don't get it. The main motive of this boot camp was to introduce you to something which is being implemented in Eevees, which can be seen in the future, and create a curiosity in you, and give you enough knowledge so that you can do sufficient research, and if you want you can pursue something in this specific domain. And we also wanted to keep you up to date with the recent updates in the EV sector. That is the motive of this boot camp. This is not necessarily a lecture or live session. If possible, in the future, we may conduct various boot camps on EV specifically, and we may have a 2-day, 3-day boot camps as well, and in which we may introduce a few projects as well, if you want.
Last week there was a session called "Saving the Ocean with Technology," but I have due to some work I have missed the session, and in on YouTube it is not yet uploaded, sir. So remaining all the sessions will be uploading, but only that one is more interesting. I thought, but not yet
Yeah, yeah,
uploaded.
yeah. Okay.
The team.
So uh, I will check and I will try and see if it can be uploaded as fast as possible. There might be some editing things to be done, and we might have to check if there was some issue regarding the recording. If not, it should be uploaded soon.
Yes, sir. Even in the classroom also the support team is there, so if they might be
Yeah, I'll
having
check.
something.
Yeah, yeah, I'll check with the operations wing, and I'll see if something can be done regarding this, and I'll ask them to upload it as fast as possible.
Yes, sir. Thank you.
I think even today's lecture you can share the link, recorded link, because some people might have joined
Yeah, yeah,
late.
yeah, yeah. So this recording will be uploaded on our YouTube channel. Yeah, I'll share the feedback link in which your attendance will be recorded. Don't worry. So yeah, if you don't have any further doubts, don't worry. This lecture should be uploaded as fast as possible on YouTube. If someone might have missed a few things here and there, you can go check it out on YouTube.
What is the status in India on this wireless charging?
Right now, we have SAE standardization adopted from 2 years, and it has been worked upon. But since the wired charging itself, the infrastructure is not sufficient enough, the goal of the government is to have at least 30% EVs on the road by 2030. So once that is being achieved, I think the government might move to this phase. I can see it being implemented in the near future in India. But right now, there is no wireless charging station as of yet. Because since this is being tested in multiple countries and the standardization, even though it's been set, they need to do significant testing in this field before implementing it for practical use. Yeah, any further doubts? So I guess we'll conclude this meet. As let's go to the review part. We have covered everything about EVs. We have covered introduction to the EV charging systems that are already existing and methods of wireless charging, introduction to wireless charging in mobile phones, how it is being implemented in EVs. So yeah, thank you for joining everyone. Keep learning, keep exploring. Again, a vote of thanks to VIT for having such a huge collaborative event. It's an honor to have a collaboration with such an esteemed university in the country. Yes, before going, I'll share the feedback link. You all can take the feedback link in the chat box. Once you fill it, you make it complete.
Thank you, sir.
Yeah, thank you for joining everyone. I hope you learned something new, and I hope this was a pretty good interactive session for each and everyone else.
Thank you, sir.
Yeah, thank you again for joining. I hope to see you all soon. I hope that in the future boot camps, I see students like you who are enthusiastic